First one will be Chrysanthemum 6. Very pretty. Second one will be Chrysanthemum 6 Extra. Very long hanging sparks. Third one will be Blonde. Very pretty. Brighter, shorter sparks than spark duration than Extra, but brighter and just about the same burning speed as Chrysanthemum 6. At the end of that last lesson on making pumped stars, I showed the stars in flight, testing them to see what the different effects were that they made. I used a star gun to fire the stars into the air. A star gun is essentially a single mortar that we load the star into to shoot it in the air. But why? Why can't I just set it on the ground and light it with my torch and see what it does? With some stars, we actually can do something like that. If I have a color star, a red color star, I want to see what color it's producing. I can set up a white backdrop like a sheet or a piece of poster board outside, set the star on a brick or something in front of that poster board, put a piece of visco going to it, light the visco. When the star burns and reflects its light onto the poster board, I'll see what color it's making. That's an acceptable way to evaluate the color that a color star is making. But a tailed star, like a glitter star, a charcoal streamer star, a metal spark streamer star, really has to be flying through the air to be so its effect can be evaluated. If I just light that on the ground, first of all, it's just going to burn very rapidly, sending out a spray of sparks, since that's a Chrysanthemum 6 star. A willow star, if I light it on the ground, the prime will burn off it, and then it will just gradually and slowly turn to a pile of ash. Whereas if I light one of these stars and evaluate it flying through the air, I can see what sort of a spark trail it's leaving. I can evaluate what the burn duration is, how long does the star burn for flying through the air. I can even take a video of it to view later on and time it more precisely and evaluate the effect more precisely. So for almost all of our stars, including color ones that we want to see flying through the air to see how large a flame envelope they create flying through the air, it's best to project the stars into the air somehow lit and see what their effect is. I have seen very experienced pyros lick their fingertips, hold a star on the edge, light and throw. They quite often also have singed fingertips. A relatively slow burning star like Tiger Tail or Willow with a black powder prime on it, that might be an okay way to test it actually. You can even wear a leather glove, light the star and toss it. You have to have quick reflexes to do that though, and I will tell you, a Chrysanthemum 6 star, that star burns in about a second, that whole thing. I do not want to light that and toss it because that will very easily burn my fingers. In the past I've used what I've referred to as the Kentucky star gun, taping a piece of visco to a star with masking tape, light the visco, and just about when the visco gets to the top of the star, and naturally I'd have a leather glove on that hand, just about when the visco gets to the top of the star, I'll shoot it into the sky, gets up pretty high, the visco lights the star, and then I can see what the star is doing as it displays its effect. So the Kentucky star gun, you can see a little singe on there. The Kentucky star gun works okay for testing stars too. But really, the best way to test a star is using a star gun. My favorite star gun right now, naturally, and this is a new design, and Caleb is making and selling these, and it's really hard to beat this star gun. All in one piece, made of aluminum. It's not going to rust and corrode easily. After I use a star gun, especially a metal one, I'll hose it out and let it dry so no corrosion is created on the inside of the holes from the residue of the black powder that launches the star out of the star gun. This has holes that range from, I think it's 1.25 inches. Yeah, 1.25 inches to 1.125 inches to 1 inch to 3/4, well, 7/8, 3/4, 5/8, 1/2, and 3/8. So a wide variety of size stars could be tested out of this. Fuse holes are in place for every size star. The fuse is inserted all the way into the base of the hole and then cut to a desired length. Nice star gun. When you deciding what size hole to use for a star, I don't want the star snug in the hole. A snug fitting star is probably going to get fractured when it gets launched out of the tube. I like a hole, I like a tube that is about a 1/16 of an inch or 1/16 to 1/8 inch in diameter larger than the star. These are 3/4 inch stars. I'll use the 7/8 inch hole in Caleb's star gun to test the stars. Very nice star gun. Sort of a more traditional design star gun. Somebody gave this to me once upon a time, and somebody did some nice welding on stainless steel tubing. Once again, this is a traditional style star gun that can be used to test stars in flight. Nice homemade star gun. I've got 3 of them mounted to this board. About 7/8 ID paper tubes into which I have rammed about 7/8 of a clay plug using my graphited clay that I use for nozzles and bulkheads in gerbs and rocket motors. I rammed a solid plug in there, very solid, drilled a 1/8 inch hole above the clay plug, and then hot glued that whole assembly to the board. Naturally, the paper tubes will be affected by the black powder residue pretty quickly, so this is sort of a short-lived star gun. If I shoot out of this, I could wash it out, but then the water is going to damage the paper. These tubes have been treated with Minwax wood hardener, so they hold up a little bit better. But that's a nice expedient star gun to take out into the field and test stars with. Another another type of pipe or tube that could be used only as a star gun, only for testing individually shot stars, is a piece of PVC pipe. This is 3/4 inch PVC pipe. It has an ID of about 13/16. So these stars have about a 1/16 inch clearance around their diameter. This is 3/4 inch thin wall copper pipe. Once again, it has an ID of about 13/16, so there's about a 1/16 inch clearance of the star going into that star gun. To make a star gun out of this, this isn't going to bulge much like the paper tubes would when a clay plug is rammed in them. I coat the inside of the very bottom of this tube with a little bit of PVC cement, and then I ram a clay plug in there the same height as the tube ID, and then drill a 1/8 inch hole above that clay plug, and then either tape that to a stake and stick it in the ground, or hot glue it to a board and use it as a star gun. But metal pipe and PVC pipe, you put anything explosive in there, from a shell to a salute, and that goes in the gun, you're going to have PVC fragments or metal fragments flying. Somebody's going to get blinded. Somebody's going to get shrapnel embedded in their body. Not a good idea. These are acceptable for use as a star gun, but it's the only place, firing an individual little star is the only place I would find using such a PVC plastic pipe or a metal pipe acceptable as a star gun. I've never done it, but using copper pipe as a star gun, it's possible to use a vise and mash, I'll use my rocket press here, mash the end flat on the copper pipe, then fold that over a little bit, and once again drill a 1/8 inch hole in the bottom of that. I'm just doing this as for illustration purposes. Like I say, I've never done it before. But if you fold that over and then take your vise or your arbor press, and what's going to be the best way to do that? Let's see. Finish mashing that flat. Now I have a well-sealed bottom on that copper pipe. Drill a hole in it. Star will drop in there to about that point, and I can use that as a star gun. Tape it to a stake and stick it in the ground. Some guys use 1/2 inch copper pipe, which is slightly larger in ID than 1/2 inch. They'll use that for 1/2 inch stars. I can use this for 3/4 inch stars, and that will make an acceptable star gun. So there are different options for making an expedient or getting a high quality star gun for testing our stars. To load a star gun for use, we kind of have to determine how much black powder to use to launch the star. I'm going to cut a 6-inch piece of Visco or so, stick it in my fuse hole. I have determined that using a Lee powder measure, Caleb has these in his store too, I've determined that for these 7/8 ID star guns, firing a 3/4 inch ID star, that the 0.7 cubic centimeter scoop works very nicely using my FFG, which is a fine black powder, lift charge. If I'm using my coarser 2.5 FABP, I would probably use a little bit more because it burns a little more slowly. I might use about a 1 cc scoop of the coarser 2.5 FA black powder lift charge. For reference, my FFG powder, which is a fairly fine commercial granulated black powder, the 0.7 cc scoop that I use of that powder weighs, it's not even registering a gram. Let's see, 2, 3, 4 scoops is measuring 3 grams. 5, 6, 7, 8, 9, 10. 10 scoops is registering 7 grams. So in fact, each scoop is weighing about 10 scoops, 7 grams, is weighing about 0.7 grams. So a 0.7 cubic centimeter scoop is scooping about 0.7 grams of that fine FFG black powder. For reference then my homemade 2.5 FA powder, I'm going to guess I have to step up at least to the 1 cc scoop. 1 cc scoop of this powder. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1 cc scoop. It's flashing between 5 and 6. If I put just a fuzz in them, well, it takes actually 11 to get up to 6, I guess. That 1 cc scoop of my 2.5 FA, 10 of those scoops is only coming up to 5 grams. Let's say I go to the 1.6 cc scoop. Just trying to give you comparable weights. 1, 2, 3, 4. That's not doing anything. What's going on here? It needs to be tearing out as it goes. Sometimes that scale will do that. I've teared 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 1.6 cc scoops of my 2.5 FA come to 9 grams. So a 1.6 cc scoop of my 2.5 FA is 0.9 grams of powder. Probably going to have to step up to the 1.9 cc scoop in order to scoop out a gram of powder. I think I'm going to have to use a little bit more of the coarser powder than the FFG. So I'd be inclined, whereas with the FFG I'm using the 0.7 cc scoop, I'd be inclined to go up to the 1.6 or the 1.9 cc scoop with using the 2.5 FA powder and do a test shot with a star to see how that lift charge works. So I've got my fuse in the star gun. I know my star gun's dry. And it's not been fired from. There's no sparks in there or anything. I've got a story in Fireworking in the safety section about bringing one of these into the shop after I had fired it, thinking it was cool, dumping the black powder in there, and the black powder charge goes off. Not a good thing. So this is a cold, dry star gun. I've got my 0.7 cc scoop. I dump the black powder charge in there. I drop my star in on top of it. Make sure it's all the way down to the bottom of the star gun. And then a very good idea is to take a couple 1.5-inch squares of paper. This is my 40-pound paper. Take a couple 1.5-inch squares of paper and shove them down on top of the star. Keeps the star from falling out if this happens to get tipped over. Also creates a little bit of back pressure to ensure really good star ignition. When that black powder charge goes and starts to lift the star is pushing against the paper, and so we know that that back pressure, that's just that little microsecond, a little bit of back pressure completely surrounds the star with flame and ensures good star ignition coming out of there. This gives a nice height. This amount of black powder charge I've dialed in gives a good, nice height to the star without blasting it too hard out of the star gun, risking fragmenting the star or risking not getting good ignition. I want to shoot the star out of the star gun about the same way it would be shot out of a mine or shot out of an aerial shell or rocket heading. I want a stout enough lift charge to fire it into the sky and determine what its effects are going to be without blasting it out so hard that it damages the star and destroys the star effect. So there's a balance to be achieved when we're dialing in the amount of black powder to use. In order to load this up, so I've got my first load there. I have, in this particular case, these 3 star guns all put on this board. And what I did to shoot the stars the other night to test the 3 different effects was I actually have one fuse hole going in this direction on this tube. I also have a fuse hole drilled here, and a fuse hole drilled here, and a fuse hole drilled here, and a fuse hole drilled here, so that I can run fuse from one tube to the next. I actually should have put this fuse in before I loaded that first tube, but I think it's in there pressed against the star good enough. I would normally run this fuse all the way to the other side of the tube and this fuse to the other side of the tube like that. And then I'm going to run a fuse from the inside far wall of the tube to the far wall of the other tube. And that allows me to make a little cake. That's the beginning idea to making a cake. Faster fuse could be used. The tubes could be closer together. And a cake can be made, a repeating tube device. If I was going to do that, I would use a little hot glue to seal up the entry fuse hole of each fuse and lock that fuse in place, prevent it from being dislodged when one of the little stars, or in this case it might be called a comet, is fired out of the tube. But there then is how I loaded. I'll put stars in, I'll put lift charge in these two and put squares and drop the stars in there, keeping track of which stars are in which place, so I'm trying to evaluate the different effects. Last night, and in this case I've got chrysanthemum 6, chrysanthemum 6 extra, and blonde chrysanthemum 6, blonde streamer. So I've got a lift charge in each tube. I'll drop a star into each tube, make sure the stars are down all the way to the bottom, and put paper squares on top of each star, and then that's ready to take out and fire. So that's how to use a star gun, what kind of star guns we could use, why we use a star gun, and I'll show the results. I'll video this one more time from a little farther distance to show the stars being fired out of the star gun. So that's a little bit of info on how to test your stars once you've made and dried them. If I was using cubic stars, like cut stars, once again, I do want the star to drop in loose into the hole. They won't fit quite as nicely as a cylindrical pumped star does, but a 1/2 inch cut star would drop probably nicely into this 5/8 inch hole, or is that the 3/4 inch hole? That's the 3/4 inch hole. Probably drop nicely either into the 5/8 or the 3/4 inch hole, and they would be loaded the same way. So either cylindrical stars, cubic cut stars, spherical rolled stars, any shaped star can be fired out of the appropriately sized star gun. Naturally now, after I have the star guns loaded, I treat this like a loaded gun. I don't put my head or a hand over that, especially when I'm lighting it. If I take it out in the field and light it, I'm going to keep my body off to the side and light that with my propane torch and then retreat. I don't have any body part anywhere near the top of that little mortar, that little star gun. Treat it like a loaded gun. I don't have any body part over it when I'm igniting this whole system. I definitely don't want to take a star at 100 miles an hour in the eye. So treating this safely, firing it safely in a safe location with no body parts over it are important safety practices. Really, that blonde is my favorite, although the extra is very nice too.